Hi everyone, in this video we are going to see how to sign the API request and validate it on the server. So before we start, let's try to understand why do we really need to sign the request. If you are working on some of the APIs which has sensitive information of a client, here we have the client, we have the server. Now, there can be some sensitive information which is going in the payload. For example, we have the payload that consists of the from account, to account and the amount, right? So now this information is sensitive. Some man in middle attack happened, and because of that attack, this to account has been changed or this amount has been changed. So for the server, it is the same request. So server will process that request and it will send the amount to invalid or fraud account. So it can be a disaster on the server side. How will server identify whether there is some tampering in the request? For this very purpose, the signing and the validation concept comes into the picture. So what happens is, whenever any request is being sent to the server, if it has some sensitive information, so on the client side, first of all, clients generate the hash of the payload. So whatever payload we have, client generates the hash and it sends the payload and the header that consists of the hash. Whenever server will receive the information, for example, it has received the payload P2 and it will again generate the hash for this payload, and here it will generate the hash, say S2. If H1 and S2 are same, that means there is no tampering in the request. If it is changed, that means there is some change in the payload. It could be any change, but there is a change and server will not process that particular request. In order to ensure that the hash that has been generated from the payload of the client and whatever payload has been received on the server are same, the same technique is used, and this is the SHA 256 algorithm that is used here. So here we have the SHA 256 algorithm. To use this algorithm, first of all, we need the key. And the key has to be 256 bit, that is 32 byte. And now we have this key K1, and the same key has to be used on the server to ensure that the same hash is being generated for the same request. If it is the same key every time being used, so it can be already saved in the client and the server. But there can be a possibility that this key is compromised. And now the intruder has this key, and whenever this man in middle attack is happening, it can generate its own payload, and with the help of this compromised key, it will generate another hash, and this hash is sent to the request along with the payload. Now, server will receive this hash and the payload, and server has the key, so it will generate the hash again. This time it will be same because the hash is generated based on the new payload, and whenever server will generate the hash for that particular payload, it will receive the same hash. So server will be in the problem and it will not be able to identify the tampering of the request. To ensure that we are not going through the same problem again, we need to have some mechanism of randomization of the key so that it will not be compromised. So in this way, whenever client generates the hash, it will use the new key. Okay, so this key will be used to generate the hash, and now server has to regenerate the hash for the payload it has received. So same key has to be used. That means this key has to be shared in the request. Now, if we share this key in the flat form, then any intruder might get it and then will generate the new payload, generate the new hash. So we will have the same problem again. In order to be in order to have the security of this key need to be encrypted. And for the encryption, there can be different algorithm can be used. For example, the asymmetric encryption or symmetric encryption, or simply we can use the public private key combination. So here on the client side, client will encrypt this key with the help of public key of the server, and now on the server side, server will use the private key to decrypt this encrypted key, and it will again get the key, and with the help of this key and the payload it will generate the hash, and this hash will be compared with the hash that is part of the request header. And this is how the validation can be done, and it can be done securely. So this is all about how we can sign the request and validate it. I hope you enjoyed this video. Thanks for watching. Happy coding and stay tuned for the next video.